Hey y'all, this is your March district test. Be sure to circle your answers on your answer document. To bubble your answers in on your answer document and circle your answers on this page. Put your name on this also. All right, number 1 says, the picture shows the motion of a ball dropped from rest from the top of a 2-story building. Use the picture to answer the 2 questions that follow. And you have your picture here that has point 1, point 2, point 3, and point 4. And it says, when does the ball have 0 kinetic energy? A, point 1 and 2. B, points 1 and 4. C, points 2 and 3. Or D, points 3 and 4. All right, number 2, using the picture still, says, at which point does the ball have the most potential energy? F, point 1, G, point 2, H, point 3, or J, point 4. So you needed the picture to answer both of these. All right, number 3. It says determine the speed in meters per second of a bowling ball that rolls 12 meters in 2.2 seconds. Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. So you're going to have to round, it's saying. You're going to do your calculation and then you'll have to round. And be sure to bubble that into the griddable. You might want to pause here to do that calculation before you turn to the next page. All right, if you're done with the calculation, go ahead and turn. Number 4, the diagram below shows a roller coaster car and a roller coaster track. Use the diagram and your knowledge of science to answer the question that follows. So it says, at which point would a roller coaster car have the most kinetic energy? F, point A, G, point B, H, point C, or J, point D? All right, number 5. Here's the directions. The diagram below shows a ball rolling down a hill. Use the diagram and your knowledge of science to answer the questions that follow. So for diagram A, the ball is here. On diagram B, you see the ball here. On diagram C, the ball is here. And on diagram D, the ball is all the way over here. And the question says, the ball at rest at the top of hill in box A possesses, so box A here, A, potential energy but not kinetic energy. B, neither potential nor kinetic energy. C, kinetic energy but not potential energy. D, some potential energy and some kinetic energy. All right, if you're ready, go ahead and flip the page. Number 6. Students begin to measure the speed of a ball rolling down a ramp. The graph below shows their results. So you have your graph here, you have your distance, and you have your time. It says, what is the average speed of the ball? So you might want to pause and do your calculation from the graph. And then you're ready, press play to hear me read the answers. All right, so after doing your calculation, is it F, 4 meters per second? G, 5 meters per second? H, 14 meters per second, or J, 20 meters per second? Number 7, a student walks for 2.0 hours and travels 5.0 kilometers. What is the average speed of the student? You might want to pause and do your calculation, and when you're ready, press play to hear the answers. Is it A, 2.0 kilometers per hour, B, 2.5 kilometers per hour, C, 3.0 kilometers per hour, or D, 5.0 kilometers per hour? Number 8, a toy car rolls 16 meters in 4 seconds. What's the average speed of the toy car? Go ahead and pause and do your calculation. Is it F, 64 meters per second, G, 4 meters per second squared, H, 12 meters per second, or J, 4 meters per second? When you're ready, you can go ahead and flip the page. Number 9. The graph below shows the distance and time traveled by a remote-controlled car. So you have your distance, you have your time. Which of the following is correct about the motion of the remote-controlled car? A, it's traveling at an increasing speed of 12 meters per second. B, it's traveling at an increasing speed of 6 meters per second. C, it's traveling at a constant speed of 12 meters per second. Or D, it's traveling at a constant speed of 6 meters per second. Number 10. Sir Isaac Newton realized that the same force that acts on falling objects also keeps the planets in their orbits. He called this force F, electricity, G, friction, H, gravity, or J, magnetism. Number 11. Changes in the motion of an object are determined by A, its density, B, the size and direction of forces acting on it, C, its chemical properties, or D, the renewable resources available. When you're ready, you can go ahead and flip the page. Number 12. It's kind of hard to see the whole question, so I'm going to try to move it up. Okay. It says the table below shows the data points of a lizard that started from rest and then started looking for food. So it gives us the points for time at 0, 1 second, 4 seconds, 5 seconds, 8 seconds, and 9 seconds. Then it shows us the distances at each of those times. So at 0 seconds, he had gone 0 centimeters. At 1 second, he had gone 4 centimeters. At 4 seconds, he'd gone 4 centimeters. At 5 seconds, he'd gone 6 centimeters. At 8 seconds, he'd gone 2 centimeters. At 9 seconds, he'd gone 4 centimeters. Using the table, which graph shows the motion of the lizard as it looks for food? So you need to use the table to match it with the graph. When you're ready, go ahead and flip the page. If you need to pause and do this one, you can though. Number 13. The graph below depicts the motion of a squirrel leaving its nest to search for food. Use the graph to answer the question that follows. So here's our graph with distance and time. The question says, which part of the graph represents the squirrel returning toward its nest? A, line Q, B, line R, C, line S, or D, line T. Number 14. The illustration below models our solar system. So you have the sun and the planets. What's the main problem with the model? So what's the problem with this model? F, it does not include the orbit paths of bodies in the solar system. G, it does not reflect the true distances between bodies in the solar system. H, it does not show that the sun is larger than the planets. Or J, it does not show the size and location of each planet's moon. All right, if you're ready, go ahead and flip the page. Number 15. Without gravity, objects in the solar system would A, orbit much faster, B, orbit much slower, C, move in straight lines, or D, stop moving altogether. Number 16. While gazing through a telescope, Alexei noticed a bright spot moving fast through the sky. On closer examination, she observed the spot was followed by a stream of hot dust. Alexei most likely observed F, an asteroid, G, a comet, H, a meteor, or J, a moon? Number 17. The planets in Earth's solar system follow A, elliptical orbits largely governed by the force of gravity. B, spiral orbits largely governed by the force of friction. C, circular orbits controlled by electromagnetic force. Or D, irregular orbits controlled by nuclear force. Last one, 18. The picture shows a car on a racetrack. We have force from friction pushing this way, force from the motor pushing this way. If the car was in motion on the track, how would the car be affected if the force of friction and the force from the motor were equal? F, the car would maintain constant motion. G, the car would come to a complete stop. H, the car would increase in speed. Or J, the car would decrease in speed. If you need to pause and rewind to go back to a question and redo it, you're welcome to do that right now. Go back to any question you need to. If not, go ahead and turn your test and your bubble sheet in how your teachers asked you to, and put your computer where it needs to go when you're done. Thank you.